This is a fun question, challenging but fun. So I encourage everyone to pause the video right now and just try solving it. Try doing it multiple ways. And if you come up with different answers, try figuring out which one is closer or the correct answer rather than the other. So that would really maximize your learning and tell you the advantage and disadvantage of each method. And possibly you will get to reflect on what assumptions led you to a wrong answer earlier. All right, so with that said, let's begin. A drowsy cat spots a flower pot that sails first up, then down past an open window. So there's a cat sitting at the window, and what he sees is a flower pot which goes up. So let's see, this is our flower pot. It's gonna go up in direction, and then comes back down. And the pot is in view while it's going up, so it can only see whatever it's in view. It is only there for half a second, and the top to bottom height of the window is 2 meters. So this height is 2 meters long, and the pot goes like whoop, right? How high above the window top does the flower pot go? So one interesting bit over here is that the pot is in view for a total of 0.5 seconds. So this pot is going up, then comes back down, and that total count is half a second. So it moved up all the way. So while it's passing this 2 meter length for the first time, it took half that time because it goes down again, right? So time, so we know some information, which is it travels some initial distance. Let's call that S. When S is equal to 2 meters initially, it does that in a time frame of 0.25 seconds. Again, half of that, because that's the total time while it goes up, disappears for a bit, comes back down, and you count the time more. That total time is 0.5 seconds. Top bottom height of the window is 2 meters. Again, how high above the window top does the flower pot go? So we have very little to figure out what's going on, right? We don't know how fast this was going, right? So let's assume one thing. There was nothing below this. The pot actually was launched from the base of the window, and we'll see how that'll really help us in the long run, because we actually have no idea about this, how this really simplifies the problem. So let's assume it has an initial velocity of u, right? Can we calculate u? Can we calculate this initial velocity? So let's use the equation. S is equal to ut plus half at squared. And this makes sense because we have time, we have an initial velocity, we have acceleration or deceleration because it's undergoing deceleration. We want to know what that initial velocity was. So the distance is 2 meters. Initial velocity is something we want to find out. The time is 0.25, a quarter of a second, plus, actually it should be minus, right? Because we're taking up as positive because our distance is positive over here. So our deceleration, it's actually decelerating, so it's negative. 9.81 times 0. Quarter squared, which we know what that is. Divide that by 2. Let's solve this. We're getting the velocity as, the initial velocity as 9.22 meter per second. Now after this, I have a very quick way of figuring out how high above the window does it go. So let's move on to the next, or like a little to the bottom so we can do more math. All right. So we have our flower pot that's going up and climbs a height, let's say h, then falls back down. So what's the best way of doing this? There are multiple ways, but I feel like introducing something different. Very easy to do. We can use the same equation again. Actually, we don't have time, so we can use one of the Newton's equations without time. So very easy, we've done it before. But here's a unique way of doing it. So recall from our O levels that kinetic energy or energy is conserved. So this thing, because it's traveling at 9.22 meters per second, has some kinetic energy, right? All of that kinetic energy is being reduced because it is gaining height, and all of that will change into potential energy or gravitational potential energy, right? So kinetic energy for this vase will turn into gravitational potential energy, right? Very straightforward. But we don't know the mass of the vase. Would that affect us? So let's take a look at if it does affect us. So the kinetic energy is given to us by half mv squared, and the potential energy is gain in height of something with weight, right? So we don't know the mass, but the good thing is they're both equal, and mass is kind of just multiplying on both sides, so we can easily get rid of the mass and we don't have to worry about it. That's the magic when you put everything into equations. And now it's just v squared equals to 2g delta h, and let's solve now. So making h the subject, we get v squared over 2g, and yeah. So that's 9.22 squared divided by 2 times 9.81. And we get the height as 4.33 meters. That's the height attained by the vase from the window space, right? And again, we didn't need to know how below is the vase traveling for before the cat sees it. It doesn't really matter because all projectile motion is symmetrical or can be continued. So a vase that was, let's say, shot up at 100 meter per second, but when it slows down to, let's say, 9.22 meter per second, and as soon as it reaches 9.22 meter per second, another vase was shot up at the same time. So for that motion, both vases, A and B, that started off really fast will have the exact same motion, and that's very incredible to think about. But I hope this question helped, and I hope you saw, even though the question looked very tedious, we just wrapped it up in 2 easy equations.